Lesson 13.6, finding key features of a parabola from general form. So remember, general form doesn't tell us anything about it. It's kind of like a standard form. It doesn't have parentheses. We can't see where our vertex is at or anything like that. So we have to try to fix it by doing some kind of completing the square like we did with circles. So if I see this, for one, I don't like the fractions. So my first job would be to take this whole equation and multiply by the least common multiple of the denominator. So I see 20, 10, and 20. I can't ever go smaller, but I can go a number that I see or bigger. And so the least common multiple here would be 20. So I'm going to take the whole thing times 20. Distributing that, that would get a 20y equals, this is over 1. So look at the 20s would cross cancel, because this would be a 20 over 20 is 1. The 20s are canceling to be a 1x squared, or just x squared. Here, the 20 divided by 10 would be a 2 left over, so 2 times 7x would be 14x. If you didn't get that, you could do 20 times 7, which is 140, divided by 10, which would be the 14. But I'm just seeing that 20 divided by 10 is 2, so I have to take 2 times 7, which would be 14x. And then last term is 20 divided by 20, so then it's just minus 51. Okay, we're going to complete the square only with the part that's being squared, which in this case is the x's. And so I'm going to have x squared plus 14x, and then plus my blank. I'm going to move the negative 51 to the other side. So I'm going to have 20y plus 51 plus blank, because whatever I add in here, I've got to do the same thing on here just to keep it balanced. To find this magic number, we're always taking the b term divided by 2, so that's 7, and squaring it. Magic number is 49. Over here, I should be able to factor this. This should make a perfect square trinomial. So what two numbers multiply to make 49 that add to make 14 would be the 7. So I put that it's to the second power. Over here, I want to combine my 51 plus 49. Well, 50 plus 40 would be 90, plus 10 would be 100. And then what should happen over here is that I have something I can factor out, which is a 20. So that would leave me with a y plus 5, right? 20 times 5 makes 100. So now this should look like conic form. The only difference is usually this was first, but if it helps you, you can do that. You can have x plus 7 quantity squared equals 20 times y plus 5. And then you might be asked one of these questions about it. So remember, the vertex is easy to find. It's just your h comma k, so negative 7 comma negative 5. Since x is being squared, it opens up or down, and since this 4p value is positive, it's going to open up. So if you wanted to draw it, you could do this. The axis of symmetry is going to cut through here. So if this is at negative 7, negative 5, it's going to be a vertical line, vux, so it's going to be x equals negative 7. And then take 20 equal to 4p, so your p value is 5. So our focus would be 5 units in here, so then that changes the height, the y, so it add 5. That would put us at negative 7 comma 0. Directrix is going to go 5 units down and be a horizontal line, so it's y equals. So if I want to go 5 units down, that would put me at a y value of negative 10. And again, I'll just ask you one of those. All right, let's try one more. We are going to convert it, so we're going to do our version of completing the square. Notice this time y is being squared, but I've got to still get rid of fractions first. So I look at my denominators, 40, 20, 40. So my least common multiple would be the 40. And something that's really nice here is if this leading term is a negative, actually multiply by a negative as well. And you'll see why here in a minute. So I distribute that to everything. That'd be a negative 40x. A negative times a negative will cancel. The 40s will cancel, so I'll just have y squared. Negative 40 divided by negative 20 would make a 2, so I have to take 9 times 2, which is positive 18y. And then your 40 divided by 40 will cancel, but you'll still have a negative 1 times 119, which is negative 119. Okay, so then I'm going to be completing the square with my y term. So I'll have y squared plus 18y plus a blank. Move the 119 over. So it'll be negative 40x plus 119 plus blank equals this. Take the b divided by 2, which is 9, and 9 squared would be 81. This should be factorable now. What two numbers multiply to make 81 that add to make 18? Well, they're 9 and 9. And then this we get negative 40x plus 80, 90, 200. And then I'm going to divide out a negative 40. So it'd be times x minus 50. Because 4 times 5 would be, no, just 5. 50 would be 2,000, too big. And again, this might look weird to you since usually we're used to seeing the squared part first. So if you wanted to write it where it's y plus 9 quantity squared equals negative 40 times x minus 5, you can. Vertex then, make sure you're going x before the y, so it's 5, negative 9. We said this is a weird one since y is getting squared, it opens left to right, and since this is a negative, it's going to open left. Okay, so that would be doing this. Putting the vertex here. Axis of symmetry is a horizontal line of y equals, so it's going to match the y value of the vertex. So it'd be y equals negative 9. The focus is going to be inside here. Negative 40 divided by negative 4. Our p-value is 10, so 10 units inside. And that's changing the x value, so add 10 to 5. That would be 15, comma negative 9. The directrix is going to be back 10 units. It's going to be a vertical line, starts with x equals, going back 10 units. I just kind of said that weird, didn't I? This actually should go back that backwards in my mind. Maybe having axes drawn would help me. So knowing that actually the focus is going left 10, so that would be subtracting 10 for your x value. So let's go back 10 down here. So 5 minus 10 would put me at negative 5, comma negative 9. And then your directrix is going to go forward or right 10. So I would want to add 10 to that. So that would put me at x equals 15. There we go.